Hello, I'm Shamik Rasnaik and I'm with two other members, Yasin Ranatung and Samita Jasena. Through this presentation, we would like to explain how we did the research analysis of diabetes dataset. We have categorized our presentation to six main topics. First one is dataset selection and exploration. Next, we did data visualization. After we built five research questions. Next, we did hypothesis testing using Python. Then we did key findings and interpretations. Finally, we find some limitations and future research directions. When it comes to dataset selection and exploration, we downloaded dataset from Kaggle. There are 128 entries and 11 features. As you can see, there are main variables such as age, gender, BMI, blood pressure, and etc. When you talk about exploration of dataset, we did a detailed analysis of count, mean value, and max value. And we identified missing values, unique values, and frequencies. Then we did descriptive analysis and summarize the data structure. Now I invite Esli to continue the presentation.
Hi, I'm Esadi Ranatunga, and I would like to explain how we did the analysis and the visualization part with Python codes and graphs, and also how we build up the research questions. In this slide, you can see there's a combination of two graphs, and the y-axis is count for both graphs, and it's similar for both. One graph, x-axis is the age, and the other graph's x-axis is the BMI distribution. From this first graph, you can see most of the people are in the age of 30 and 55 of this data set. Next to that graph, you can see a quite similar graph which their BMI index is higher than unexpected. Some people have 50 to 60 range of BMI as well. Through these graphs, we can clearly see the BMI and age may be a risk factor for diabetics. Second, Second two graphs in this slide, there's a quite similar graph to the earlier graphs, and at this time, again the count is similar for both graphs. Both explains the blood sugar level of patients with two blood tests. In here, we can see a similar interpretation, and high blood sugar level is there for count of 16 patients. In next slide, you can see three graphs, and one is a bar chart. Next to that is a box plot, and the other one is a line graph. First one shows the yes no answer whether the patient is diagnosed for diabetics or not. As you can clearly see in the graph, most of the people has not diagnosed as diabetics patients. In the second box plot, it shows the diabetics diagnosis within the BMI index. As we know, the low BMI index is healthy, but according to the data set here, this may vary due to some other reasons such as age, family background, genetics, etc. At last but not least, there's a line graph which shows the distribution of blood sugar levels by age. This clearly shows an upward trend of the blood sugar level with the age. So, next, I would like to take you through the research questions we built for our analysis. And from our very first research questions, we checked whether the family background and genetic history can impact on the increase of diabetic likelihood. Second, from the second research question, we tried to identify is there any correlation between the blood sugar level and the diabetic diagnosis. Then we try to identify whether the lifestyle pattern can impact on the prevention of diabetics. And then also we checked whether there's a correlation between the age and the blood sugar level. And finally, we built a research question to identify whether there's a relationship between BMI and diabetic diagnosis. So next, I would like to invite Samantha to explain the rest of the presentation.
Thank you, SND. Let's go over the hypothesis testing for our study. We used a p-value threshold of 0.05 to evaluate statistical significance. If the p-value is less than 0.05, we reject the null hypothesis, which means the significance association, difference, or correlation. However, if the p-value is equal or greater than 0.05, We fail to reject the null hypothesis, meaning there is no statistically significant relationship. To investigate the relationship between different factors and diabetes, we applied several statistical tests, including the chi-square test, t-test, and Pearson correlation. First, a chi-square test for the family history and diagnosis showed a significant relationship. Second, the t-test for the HbA1c levels and diagnosis also indicate the significant relationship. Third, the chi-square test for the lifestyle factors and diagnosis shows no significant relationship, suggesting lifestyle factors alone may not directly impact diabetes in this dataset. Fourth, the Pearson correlation between age and HbA1c showed no significant relationship, indicating that age may not be a direct factor in HbA1c levels. Lastly, t-test for BMI and diagnosis confirmed the significant relationship, emphasizing BMI as a risk factor. In summary, our analysis identified significant relationship with family history, HbA1c levels, and BMI, while lifestyle factors and age showed no significant link to the diabetes risk in dataset. I'll now go over the main finding from our analysis on database diabetes risk factors. We found that family history and genetics have a strong link to diabetes diagnosis. HbA1c levels, which reflect blood sugar over the past 3 months, are significantly higher than those diagnosed with diabetes. Lifestyle factors like diet and exercises surprisingly didn't show a significant impact. There are also no significant relationship between age and HbA1c levels. Lastly, BMI is higher in diagnosis individuals, showing a positive correlation with diabetes. In summary, family history, high HbA1c levels, and higher BMI are key risk factors for diabetes, while lifestyle patterns and age seem to have a less direct impact. Our study had a few limitations, a small sample size, potential bias in self-reported lifestyle data, and cross-sectional design, which doesn't show cause and effect. Future research should be use data over time, include larger and more diverse population, gather objective lifestyles data, and consider age-specific analysis. This concludes our presentation. Thank you.